Okay, 7.4 is reasoning with slope fields. So we're just going to use what we've learned about slope fields and see what kind of conclusions we can draw or how we might use that information. Okay, example 1. Given the slope for the differential equation dy dx equals 1 minus xy. Part A, sketch the graph of a particular solution that contains 0, 2. Label this point as point A. Okay, so they've given me the slope field. This is the graph of this. It's the slope field for this function. Sketch a graph of a particular solution that contains 0, 2. Okay, so let's just find 0, 2 on the graph and label it as A, because that's the easiest part. Okay, so 0, 2 is about here. Let's call this A. Okay, now if that function passes through 0, 2, I can use the slope field to kind of follow the trajectory of the graph. So I can see the slope here is kind of going this way, this way, this way, this way. It's kind of going, so let's draw that part in. Okay, so it looks like it's going up this way. It's kind of heading down this way, this way, this way. And then it kind of goes down here. And then what's going along here? It looks like it's going towards an asymptote, actually. So that's probably what the right side's doing. Okay, now let's look at the left side. Okay, let's see. It's probably going down. Slope is negative, negative, negative. And then it kind of looks like it's leveling off right around there. So that's my graph of a particular solution that passes through 0, 2. Okay, let's look at B. B says sketch the graph of a particular solution that contains negative 1, negative 2. Label this point as point B. So negative 1, negative 2 is here. Let's call that B. And then I'm going to use the slope field to kind of sketch which way this is going. So it's kind of going this way. Looks like it's going up, positive slope, and then it kind of levels off here, which looks like there's some kind of asymptote there. Now look on the left side of B. Looks like it goes this way, this way, this way, and it's also leveling off right here. Okay, so both of these graphs have the same slope field, but because of their particular solution, I can find a guess for a graph of their particular equation. Okay, let's look at example 2. Example 2 is a multiple choice question. Okay, so for example 2, the slope field for a certain differential equation is shown to the right. This is the slope field. Which of the following could be a solution to the differential equation with the initial condition y of 0 equals 0? So I want to figure out which of these equation matches this slope field. Okay, let's consider, let's just start with 0, 0. Okay, they're telling me that y of 0 should equal 0. So let's plug in 0, 0 and see if we can get 0, we can eliminate something. So this is x is 0. So if I plug in 0, I have 0 over 0 minus 4, which is 0. Okay, let's try this one. I do e to the 0 plus 2, that's e squared. E squared, that doesn't equal 0. So c is out already. Okay, what about the tangent of 0? The tangent of 0 is 0 over 2 plus 0. That could work. And then for d, 0 squared is 0. 2 plus 0 is 2. 0 divided by 2 is 0. So I'm down to a, b, and d. Okay, now let me look at the remaining graphs to see what I can find out from this slope field. Okay, there's clearly something weird going on at negative 2. So why would there be something weird going on? Let's look at these graphs. Let's see. Well, for D, at x equals negative 2, there is a vertical asymptote, which matches up. Look at this one. X equals negative 2 looks like it has a vertical asymptote. For A, this is x plus 2, x minus 2. So there should be a vertical asymptote at x equals negative 2, which it looks like that makes sense, but also at x equals 2, which doesn't make sense because this has a defined slope at x equals 2. So I think A is out because I see an asymptote at x equals negative 2, but not at x equals 2. Okay, so now we're down to B and D. Okay, let's look at B, because B has tangent of x in the numerator. Now the graph, what does the graph of tangent look like? The graph of tangent is the one that kind of looks like this, It has all these asymptotes. So I feel like this should have more asymptotes. Like maybe at pi over 2, which should be somewhere between negative 3 and 3, but there's no other asymptotes here. So it's making me think that B would not work because there should be more asymptotes if the answer was B. So I'm thinking it is D. Okay, how could we check our answer? Okay, one, I could kind of sketch it. At x equals negative 2, I can see that the slope is undefined there. And we already figured out, because that's probably because there's an asymptote. If I were to kind of guess which way this graph is going to go, it's kind of going up. It's kind of going, I don't know, it's going to do something like this. On the right side, I can't really tell what it's going to do. It looks like it's going to do something like that. I'm not really sure. Okay, which seems to be in line with this. If I wanted to double check, I could graph this and see if it kind of looks something like this. You could also graph this to double check, but based on my elimination, it looks like the answer should be D. Okay, let's consider example 3. Okay, it says consider the differential equation dy dx equals x plus 1 over y, and it's given slope field. Describe all points in the xy plane y is not equal to 0 for which dy dx equals -1. Okay, we're going to do this algebraically, but let's first just think about what they're asking. This is the slope field over here. They want to know, when is the slope -1? So if I'm just looking at this and guessing, it looks like maybe here, this looks like -1, -1, -1, -1. So in this case, I could kind of see that it looks like all of these have a slope of -1. I'm kind of guessing, and I'm going to solve it anyways, but if I look at it, it can kind of help me confirm my answer. Okay, now let me actually try to solve it and figure out what's going on. So I want the slope to be -1, so let me set this equal to -1. Okay, now the points where the slope is -1 is going to be a bunch of points. It's not just going to be one number. Why did I put x instead of -1? Hold on, pause. -1. Okay, so let me try to find an equation to represent where these points are. Okay, so x plus 1 equals -y. So this is going to be a line. Okay, let me divide by negative. So I get y equals -x minus 1. And let me think about what that is saying. Okay, I want to figure out when the slope is -1. The slope is -1 along all the points along this line. This looks like this line. The y-intercept is -1, the slope's -1. These all look like they have a slope of -1 if I were to graph this line. So how would I describe this? Describe all points in the xy plane for which the slope is -1. Okay, the points that are going to have a slope of -1 are all the points on the line y equals -x minus 1. Okay, and let me graph -x minus 1. So this is like this. This would be the line, and it does look like the slope is -1. Even if I hadn't done the graph first, I would graph the line and then look and see, yep, it does look like the slope of each of those points is -1. Okay, let's do one more. Example 4. Explain why the following could not be a slope field for the differential equation. So this is my slope field. They gave me a differential equation. They want me to say why this is not correct. Okay, let's look at this. This is dy dt, so let's call this t. This is y. Okay, let's just plug in something easy and see if that works. So let's see, when y is 0, does y is 0 already fail? Okay, let's imagine when y is 0. If y is 0, -0.3 times 0 is 0. So the slope here should be 0, 0, 0, 0, 0, 0, 0, which it's not. Okay, so I already found a reason why this doesn't work. Let's see, so when y equals 0, dy dt should also equal 0. That seems reasonable. Okay, however, when I look at this, I see that this one's 0, but this one's not. This. However, at y equals 0, the slopes vary and do not all equal to 0. Okay, so I'm just trying to come up with some kind of counterexample proving why this is not correct. So I chose an easy one. When I plug in y equals 0, I get 0. So the slope should be 0, but it's not. It's 0, and then it's like negative, 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 which means that this cannot be the correct differential equation for this sloped field. If I had picked a different y value, like say I had picked y equals 3, negative 0.3 times 3 is negative 0.9, so the slope should be close to negative 1, and I can see it starts at 0, and it's changing. It's not always the same value, so it's not constant, so I'm just looking for some kind of counterexample. So this is one example of a counterexample I could use to justify why this is the incorrect slope field for this equation.